there must have been many things that I failed to note in this fairly lightweight presentation that you think we as a group should be cognizant of, something you care deeply about. Is there anybody who wants to stand up and say something like that? What did we miss? There's one. Would you like to come down to the microphone here? We made it very hard for people to say anything by forcing them to come down to the microphones. But
in addition to the water gas issue, what about carbon? Where, in light of Google's investment in green and renewable, how can we learn from what we do in the airplane, the security, the planes have to land, and then how do we make this all part of that sustainable resource thing that you said as it relates to climate change or carbon?
Okay, so carbon, of course, isn't the only problem. Methane is another one. In fact, I've always...
all the greenhouse gases.
Oh, right, exactly. I've been hoping that we could install a methanometer in the Congress to keep track of the amount of...
hot air.
And then harness that somehow. Let me try to respond to the question this way. We generally do not have very good feedback about the consequences of our choices. And you see attempts at this from time to time. Sometimes it's a label on the cigarette that says this, you can die if you smoke. Or sometimes it's food labeling that says, there is this kind of fat and that kind of calories and so on in what you're eating. We don't necessarily know what the consequence of buying this particular product is in terms of its carbon footprint. And here I think we have to speak written kind of large. I mean, it's not just the production of the device or the operation of the device, but sort of the life cycle. Now, whether or not we can do this label like that for every single device is probably extreme. But having on the net the ability to get information about this question, about the consequences of our choices, is important. Part of the rationale behind the smart grid theory is that by feeding back to you the consequences of your lifestyle choices about how you use energy and when you use it will cause you to change behavior, either because there's an economic incentive or maybe there's an even broader one, which is a save the humanity incentive. It's the feedback that's important. And so the slide that said it's all about information is really true, that in the absence of feedback, we don't know how to modify our own behavior. We could apply this to the healthcare system too. If you don't know how much the things are that you are asking for or that have been prescribed for you, you don't know how to modify your behavior. So although that's not a specific answer with regard to carbon, it's, I think, I'd like actually to take your question and expand it to say, how can we provide better feedback to people about their choices and what those consequences are?
And the global nature of the internet. Also, when you said Pakistan cuts off this or China wants to do that, those are that's the
yes,
global warming that we're talking about.
In a sense, that's right. Yes, the net goes everywhere, so does the atmosphere. Actually, well, this gentleman came and sat down first, so you have a shot.
Hi, thank you. Dave Watson, Lawrence Berkeley Lab. I'd like you to comment on the complexity of the systems that we're talking about. And historically, complex systems with requirements, documents, and waterfall type methodologies just don't work.
Don't work.
And so some more modern methods of rapid prototyping and iterations and so forth are better, but it's still a daunting challenge. So if you could address the systems integration and design issues.
Right. So let me focus on the design part. One of the things which has been helpful to the internet, which I hope might be applicable to the smart grid thinking, has been the layered structure of the internet. Within the internet community, we argue about this, but what has been valuable is that the layers are sufficiently separated from each other with well-defined interfaces, so there's a lot of flexibility to change things within layers. So I'm fond of pointing out the internet packets don't know how they're being carried, and they don't care. And they don't know what they're carrying, and they don't care. The consequence of that separation is that we've been able to put new transport facilities underneath the internet packets and put new applications on top without the internet layer having any idea what's going on. So looking for ways of decoupling parts of the smart grid from other parts of the smart grid can have the effect of reducing complexity and increasing flexibility. Now, that's a kind of principle. I didn't necessarily say we should build a layered smart grid, although some of those concepts may turn out to be very useful. But what I am saying is that we should find ways of doing a design that allows this kind of decoupling. Sometimes people use the term modular. I'm not quite sure that that quite gets at the sufficient separation of the various parts that you can do things to one without having a major impact on another. The complexity comes about because of interactions among the various parts of the system. So anything we can do in the design that reduces the amount of interaction among the parts, reduces the amount of complexity we have to analyze, measure, model in order to make the system work, and it may make it more robust. Let me get this one over here, and then you're next. Yes, sir.
Well, actually, a follow-up, and you partially addressed the point I was going to make. One of the issues with layering and complexity within layers is the complexity of the standards which you use to define that interoperability. And having read a lot of RFCs, even the ones that aren't requests for comment, I wonder if you have any thoughts on the complexity of standards in dealing with interaction.
Okay, so my first honest answer to this is that theorem number 206 applies. Theorem 206 reads, everything is more complicated. And in some sense, it really is true. The deeper you look at anything, the more complicated it seems to get. Simplicity, in theory, is our friend. And of course, as we've watched the internet evolve, we've seen a great many new protocols arise that didn't exist before. There are 5,500 or so RFCs, not all of which are standards, but many of them are. One thing that we might say is that if the architecture allows this separation that I was talking about before, then the fact that there are a lot of different protocols involved does not necessarily impose on the system the kind of n-squared complexity that you'd expect if everything is interacting with everything else. But it is very hard to avoid a kind of creeping complexity. And part of the reason for this is that once you get something to work, people will find ways to use it that you didn't think of. And certainly this is true of the internet. And you know, in my heart of hearts, I've been astonished that this thing actually still works. And every time I get a web page that comes back or an email goes through and I think about all the stuff that had to happen for that to work, I remember thinking, my, that's amazing. I can't believe that actually worked. So I don't have a magic pixie dust that inhibits the complexity from growing, but a sensitivity to that as you think about the nature of the architecture and the principles on which it's built can at least, I think, inhibit the rate of growth of complexity. Yes, sir.
Hi, my name is Tom Tansey from the Sunspec Alliance. My question is, what about the role of the utilities? How do they factor into this?
I'm sorry, the role of?
Utilities.
Oh, yes. Well, a utility? Why do we? I mean, who cares about the utilities? I only care about the communications architecture. Now, the honest answer, of course, is that without the utilities being a part of this, none of this is going to work. One area which I alluded to earlier is that to the extent that you understand how to design and build the system to protect itself from the potential hazards of the information and control flows that we are introducing that didn't used to be there. I mean, we are adding something to the power environment that didn't exist before, and that's demand response. Just monitoring and providing information, I think, is, to first order, relatively harmless, not counting the possibility of compromised devices and potential security threats. But the fact that we're introducing some control, some responsiveness that we're anticipating adds to the risk factors. So the utilities need to do several things. First of all, you need to help make sure that the system can defend itself against unexpected side effects. The second thing is to help us understand the economics that you are relying on this smart grid system producing. Example, if we make the argument that by building demand response into the system, we remove the need to build peak power generation capability because you can somehow suppress that demand, you need to help us understand the economics of that and the importance of getting this, of actually delivering on that promise. I hope that you also will pay attention to some of the physical things about the appliances themselves, and you have to make, for example, we make heavy use here in the United States of AC power everywhere. And I guess eventually when we do LED lighting, DC will probably be very common. So it's very odd in a way that over this course of the last, let's say, 100 years or so, we have shifted our usage of power to distributed power to DC. And of course, our portable power has always been DC. Yes, sir.
Ron Ambrosio from IBM Research. So you started to, you asked what didn't you mention, but you started to talk about this one, but I think it's still worth expanding on, which is unintended consequences and emergent behavior in this very, very complex system that we're going to build, where it's becoming much more dynamic. Operationally, it's going to be very different than the traditional electric systems have been. And so what are your thoughts on the kinds of things we have to do in architecting this system?
So this is a little scary for a guy who's just a computer jock to answer this question. I would expect the power guys to jump up and say, boy, you don't understand what you're talking about. First of all, I think we should give credit to the industry that has produced and distributed power for a good long time and provided it pretty reliably with a variety of different production methods. But what we are introducing, in addition to the possibility of a control system, which has the potential to be unstable, we're also introducing power generation systems that are not continuous. So wind power, solar energy, wave power. There are a variety of different things that we are proposing to introduce into the system because of their global warming consequences, because of the desire to get away from non-renewable resources. And yet we're introducing instability potentially into the system. So we're back to a question about how to design a system that has more intermittent and unstable elements in it than even today's power generation and distribution system. Now this almost certainly illustrates my limited understanding of all the stuff that goes on to get electrons delivered to everybody's house. I mean, I'm sure that it is really a complicated system already. And so, to give credit to the people who make it happen and so reliably over such a long time, they are already confronted with some pretty complicated things. But I think we're making it even more, potentially more complicated, and yet we are motivated by the global warming question. We're motivated by the problem of renewable resources or unrenewable resources to want to do that. So the challenge really is to get it done in a way that is still as stable and reliable as it has been. Yes, sir.
Richard Schomburg. I work for the French Electricity Board, and I am responsible of the smart grid activities at the IEC. I think this group is very fortunate to actually spend some time with a pioneer and a veteran of the Internet adventure.
Thank you for not saying with a dinosaur, but that.
Well, I'll let you say that. And of course, all the presentation made us dreaming that one day for smart grid, we're going to have the same exciting features as you outlined from the Internet. Now, I would be interested to know 1, 2, or 3 situations where you consider you burned your fingers along the way and that actually you would deal with it differently today.
Well, 2 of them I already alluded to. One of them is the dumbass decision to put 32 bits of address space into the Internet. even though at the time I thought it was a reasonably well-justified conclusion. The second is the failure to emphasize more authenticity, integrity, and identification in the system. Even though we kind of knew that in the long run, for some value of long run, we would need to do that. Remember, the Defense Department was supporting the research, and so in the back of our minds, at least in the back of my mind, was the need to have some of these features. If you even look at the packet formats, you can see places where we had levels of cryptography, and whether this was secret or top secret, and so on. But the timing was such that the raw materials for realizing some of those features just were immature. And on top of which, of course, we weren't sure this was going to work at all. So I think if I were to say what the most important lesson for me has been is the ability to make the system evolvable. And you could argue that we've not done a very good job. The V4, V6 transition is rocky because they're not interworkable. And as I think about it, there might have been some other ways of implementing this to make it easier to bring both protocols into operation. But there's always the problem that if you have a backward incompatible introduction of a new feature, it's very, very hard to deploy. So one question is whether we can be smarter about the way in which we design this smart grid. If, for example, we all recognize that it's not just electricity, but it's going to be all these other resources that we should be attentive to, then we should be at least thinking now about how to make sure we didn't put in roadblocks to this kind of expansibility. But those are kind of basic conclusions. Sometimes it's just really hard to have recognized that you made not an arbitrary decision, but a crucial one. And it's sometimes, for me anyway, some of the decisions, which I now know were inappropriate, seemed purely arbitrary, that it didn't matter what we did, pick one instead of picking three, right? So pick one. So it seemed more important to pick one than it was to fibrillate on it for too long. We do have that problem before us here because there is some time pressure associated with getting the work done of the SGIP. We have aspirations as a country, not merely to design and build this thing, but we want to do it soon enough to have an economic value and also have atmospheric value, so to speak, or environmental value. So we have some time pressure here, and we should be careful to do the best we can to look at things, if we think that they are arbitrary, to stop and say, maybe they aren't, and maybe there are consequences we should try to understand. Because those are, I have a few toes left, but not very many. Let me get this gentleman and then over here. Yes, sir.
Hi, I'm Dan Woods from, I write a blog for Forbes.com. Do you think that the success of the internet and all that it's achieved has given us the illusion that we could have actually designed it? I mean, the smart grid is now got such scope because it's living in the shadow of this massive thing that was not designed, but we sort of kind of have the illusion that perhaps it was, and now you're trying to design this massive thing, all these requirements, all these layers. Would it be better just to ratchet it back and design the first set of parts and then see what you could do with them?
So I have some resonance with this. Because you're quite correct that what we have now in the internet was not anything like what we had at the very beginning. Routers were pretty simple things because the topology of the net and the scale of the net were much smaller. The one thing I do kind of cling to, though, is this flexibility in the design, this attempt to decouple things from each other. Trying something out is actually a good idea because no matter how hard you do the design and how many simulations you run, if you didn't think of the thing that makes it not work, so it wasn't part of the simulation, you won't discover until you actually try it in the real world. So some of the notion of prototyping and everything else I think is very useful. But if we are to allow ourselves that flexibility, which I think we need to have, then we need to make sure that we are conscious when we do the architectural design that we keep things as decoupled as we reasonably can. Otherwise, what will happen is that no matter what we actually try out, the system won't let us try something else out, or won't let us evolve what we have from what we have. And we've been really lucky in many ways. I mean, you're quite correct that the internet of today was not what was designed in 1973, although kind of from a high-level functionality point of view, it looks pretty similar. But the details have changed a lot. Yes, sir?
Yes, on the question of security, I find it really fascinating because of your background coming from the government and going to the work that you did, that originally, like you said, the internet was all about creating connections, and that kind of goes against what the government's used to doing even today. From a point of view of security, they're much more comfortable having 3-ring binders fly around instead of sending a file. In fact, I had that problem today, having to send a binder to Washington, D.C. But I'm finding that the question of security, actually, a lot of times it's actually more dangerous to not have access to information, like what happened in Times Square, being able to communicate that this person's getting on the plane, for example. So that's one thing. The other thing, I find it interesting from your perspective of being in Google now, too. I mean, as you talk about the postmaster in Germany, Google sometimes is accused of having too much information. So I'm wondering if you have a direction that we could take from the utility point of view that we could actually help to break this open somehow, to really show the value, yet still have that security. There probably isn't an answer yet, but it's an interesting discussion.
So first of all, the idea of sharing information is very powerful. And every time I have seen societies that suppress the exchange of information, they also often suppress innovation because there isn't enough sharing. So even setting aside the security example that you gave, the ability to learn from each other is really important. That's why I'm a big believer in open standards. That's why I'm a big believer in open source software and things of that kind, simply because we learn a lot from each other if we're willing to share. The problem that you're describing about, for example, the situation with the Times Square bomber, we often deliberately hide information or compartmentalize it because we think that the exposure of the information will somehow have a risk, like somebody will figure out what it is that we can know and then defend against it. My conclusion there has always been something like, why don't you pour all that stuff together in a big vat and let all the correlations happen, and then if you need to do some access control, put it at the edge of the system. So if you have an analyst that's looking at something and the system says, I found a correlation, but I can't tell you about it because you don't have privileges to get to this piece, then that analyst ought to have the ability to say, there's something in there that I'm not allowed to see, but somebody who is allowed to see it should look. So, I mean, that's the sort of sharing of information, another kind of sharing of information that I think is important. The one thing which I wonder about this is a question actually for the folks who actually run power utilities, is how much information they might worry about having the general public having access to. I've already mentioned the privacy problem of having a lot of information about an individual's consumption of power and the inferences that you can make from that. So there you have this tension between information that I might want to know because I'm trying to understand the consequences of my choices and how much I want my neighbors to know. I mean, to give you the extreme example of this, suppose that there is a general belief in the United States, and especially in your neighborhood, that you should be green in your choices and decisions. And it turns out that you don't care, and you have enough money that it doesn't matter, and so you burn, lights 24 hours a day, and you've got, all these little transformers going everywhere, and your neighbors find out, and, they stick a thing in the middle of the lawn which, says that you're not green. You know, now suddenly you have a social problem on your hands. So I don't know where to draw that line, but I do know that people care about their privacy, and we need to be cognizant of that. Yes, sir.
Today we have 3,100 plus utilities, 53 plus public utility commissions, plus who knows how many other regulatory agencies. Back at the beginning of the internet, you had 4 sources of information that wanted to share information. 1 regulatory agency, the U.S. government.
Actually, it was just DARPA.
DARPA, so 1. So can you draw any parallels on the role of regulation and governmental policy, or lack thereof, on the internet versus what we have today and what we're starting with in smart grid? And any parallels or lessons learned on the role of regulation in either enhancing, stifling, otherwise impacting what we're trying to do here?
So the most general thought that I have relates to the design. Let me start there and say that over-specifying is the biggest mistake we can make, and that's come up in several ways, where people have the waterfall idea, which we know doesn't work, even iterative kinds of design don't guarantee to get to where you want to go. So one aspect here is to be very careful about not over-specifying things. When I hear requirements, I always get nervous, because I worry that people don't fully understand the requirements, and they won't until they actually are living in this environment. There's an example, by the way, that I was told about in China. I used to be on the board of a company that made optoelectrical equipment, and when we sent our requirements, our specifications, to an outsourcer, we were very, very detailed in what we wanted. And generally speaking, we got back pretty much exactly what was asked for. Our Q&A people were careful. This was not Google, by the way. It's just another company. And then we noticed that a competitor, a Chinese competitor, was able to produce equipment that didn't cost as much as ours did, but it worked as well or better. And so we started asking, well, why is that? And the answer was that they didn't over-specify the requirements. They specified what they absolutely had to have, and they left it open, left the design open to innovation from people who were doing the actual manufacturing, who had understandings about what it took to manufacture something, or what it took to maintain something, what the life cycle was going to look like. And that freedom allowed them to do some designs that were better than the over-specified case. So at least one lesson for me has been to be very careful about not over-specifying everything and leaving some room for innovation to take place. On the role of regulation, gosh, it's such a huge topic. I mean, the economic side of things, and rate regulation versus competition. Where there isn't much competition, regulation is often brought in to try to keep things fair. What I don't understand, frankly, about the smart grid of the future is the role of local power generation. The windmills and the solar power, and maybe the cars that can dump some of their power from the battery back into the system at need. We've never really had a large-scale system that I know of that has that capability. That adds complexity to the system, but it also produces potentially some very funny incentives, like I want to stay off the grid. And if I can stay off the grid by using my own power generation, then what does that do to the economics of the utility? And they were relying on some expectations of what people were going to consume when they built their power generation capability. And now I come along and I make an investment which I'm optimizing for my own pocketbook. And all I'm doing is essentially echoing the question, and maybe in a more elaborate way. I do not have a good answer to this. And we're back to a pretty complex environment. So I'll give you an example of an idea that I would have, which is probably a terrible idea, and somebody will, after this is over, throw a bottle of champagne at me or something. But one possibility is to say, okay, for all of you guys who are generating power, I'm going to allow you to generate power, locally, and use it to not consume power from the grid, but I'm not going to have you dump power into the grid. Now, that may be a stupid idea, but it's an attempt to speak about interlocks and interfaces that simplify things by not letting the local power generation interfere with the distributed power. Now, somebody will surely stand up and say Kirchhoff's law hasn't been repealed, and if you generate power, it's going to go wherever the least resistance is, and so that's a dumb idea. And I accept that if that's correct. But the idea of finding ways to limit the amount of interactions that take place has got to be important.